Hi students, today we'll discuss a new topic, that is work power energy. So this from this chapter, no, actually this is only the basic chapter, so where the total physics is involved onto this. No. From here only we will calculate, everywhere we will calculate the energy and work done, all this one. No. So the basic one, it will comes from this chapter only. If you really want to learn the physics, no, compulsory you should be very thorough in this chapter. Okay. So first let us see what is work done, or when the work is said to be done. Right, work done, most of the students know, they will learn something, right? So they will sit for hours together and learn something, prepare. They will say that, they will tell, I did lot of work. Okay, so therefore these type of things, no, it is doesn't mean that it is a work is said to be done, right? So we cannot able to identify that, really we cannot able to visualize that is whatever we are work done onto this, right? So in physics, no, therefore these all are not said to be like a work done, no. So when the work is said to be done, so suppose if any object is there, therefore we are exerting the force on this. Therefore, due to that force, the object will displace. That means object will move from one point to another point due to the application of the force. Then the work is said to be done. So when you are exerting the force, so that object is displacing, so then only the work is said to be done now. So how we are going to define now? Okay, let us see. So one more time, when the work is said to be done, right? So work done. So when the work is said to be done now, suppose there is a one ground is there, no. So therefore upon to this there is a one box is there, right? So you are exerting the force on this one, no, right? So here you are exerting the force on this force, and due to this force, no, therefore this object is able to displace. So if an object is able to displace, then only the work is said to be done. How to calculate the work done now here? So work done, therefore work done we can write it as like a force into displacement, right? So suppose here the force is there, no. So here the force is we are exerting the force by making an angle. So suppose here the force is there, no, it is making an angle theta here, no. So therefore if you try to see this, no. So this force now we are going to split it into two components. So therefore here this f cos theta, and therefore this side it will be f sin theta. So here this object is able to move. By how it is able to move? Because of due to this force only. This force is not making an object to move. That means this force means making the object to go toward this side. This object is not going in this direction. This object is going in this direction. Only this force did the work done, no. So therefore we can rewrite it as this formula. Therefore f into s, that is f cos theta into displacement. Now you can rewrite it as here. So one more vector form we can write it now, that is f dot s, right? So in this way you will calculate the work done. So let us see the basics onto this one, no? So basic units, right? So what are these units, no, and what are the dimensional formulas, we'll see now. Basic things, no. What is the SI unit of work done now? Work done, so force into displacement. Therefore force is nothing but, what is the SI unit now? SI unit. So force is nothing but Newton into meter. So if you are 1 Newton is exerting, so that object is moving 1 meter distance, no, then so 1 joule of work is said to be done onto this. Clear? So similarly in a smaller units, no, like a CGS unit you can write it now, CGS unit. So therefore what is the CGS unit of force, no? That is nothing but a dyne into centimeter, right? So dyne into centimeter, 1 dyne and 1 centimeter. Dyne is the smallest unit now. So this is said to be like a 1 erg. So we can have the relation between these two, that is 1 joule. What you can write it now? 1 Newton into 1 meter. Therefore so 1 joule and is equals to 1 Newton into 1 meter. 1 Newton can be written as like a, so 10 to the power of 5 dynes. 1 meter is equals to 10 to the power of 2 centimeter. So therefore here 10 to the power of 7 dyne into centimeter is nothing but a erg. You can understand erg is a very very smaller unit now. Clear? So 1 joule is equals to 10 to the power of 7 ergs. So we can rewrite the dimensional formula here, no? Dimensional formula. So what is the dimensional formula? Force is nothing but m1 L1 T minus 2 into L. L is nothing but here you can write it as. So therefore here L2 will be the dimensional formula. Now work is equals to F force vector dot S vector. So therefore work done is a vector or scalar. So work done is a scalar quantity. It is a scalar. It is a dot product. So there is no dependence on the directions on this one, right? So here, so these are the some basics onto this one. No? So when okay, so there is a when positive work is done, when the negative work is done, when the zero work is said to be done. No, we'll see the special situations now, right? So we already calculated work done, it will be equal to F into S into cos theta, or force component or displacement component, anything you can rewrite it as now. So when the work is said to be done is positive, no, positive. So work done is positive, very important, understanding is most necessary here. Work done is positive. When the work is said to be done is positive, so here cos theta are positive and maximum, right? So therefore cos theta, therefore here, so work done is positive, therefore also maximum work done, no, maximum work, therefore when you can write it now plus F into S, right? So when it will be now cos theta, it will be equal to 1, therefore theta is equals to 0. So that means what? Therefore, if an object is there, this one object, so in this direction you are exerting the force, in the same direction object is moving, in the same direction object is moving, then work is said to be done is positive. That means work done is positive means force and displacement both should be in the same direction now. Clear? So when the work is said to be done is negative, no, negative. This is important, no. So work done is negative. So when the work is said to be done is negative, so work done it will be equal to therefore minus F into S. When it will get it now, therefore cos theta it will be equal to minus 1. Minus 1 means what? Theta is equals to, so therefore 180 degree. That means in the opposite direction. So that means here, so suppose you are exerting the force, right? So if you are exerting the force in this direction, so force in this direction, no, but object is moving in this direction, no. Or like suppose here you can rewrite it as here. Suppose if the object is going in this direction, no, so but here the frictional force in it will act in which direction now? Frictional force is going to act in this direction. We are exerting the force here now. So who did the positive work? We applied the force, no. Therefore applied force, we did the work. That means applied force, work done by the applied force and displacement, no, both are in same direction, work done is positive. But frictional force will act in which direction? Opposite direction now. So this side direction frictional force is there, displacement is in this direction, no. So work done by the friction is negative, right? Work done by the friction, work done by the viscous forces, no. So like that was work done by the air resistance, no. So these all are said to be like a negative work done. Clear? So this understanding is very important, no. So now let us go for another one more concept, no. That is when the work is said to be done is 0. When the work is said to be done is 0. This is also important, no. Very important. When the work is said to be done is 0. So work done is 0 if there is no force is acting on this one, no. Force is not at all acting, therefore, so work is said to be done is 0 onto this. Clear? So no force is acting on this one, no. Clear? So also displacement is 0. Displacement is 0 means what? Suppose you are pushing the, you are exerting the force on the wall, so but wall will not move, no. Therefore the work is said to be done is 0, right? So like that, if there is no force is acting, or work is said to be done, work is said to be done is 0. So displacement is not there, work is said to be done is also 0. Also, if it is theta is equals to 90 degrees, this is important. That means force and displacement both are perpendicular. When force and displacement both are perpendicular, then the work is said to be done is 0. Therefore, here perpendicular means what you can write now in a circular motion, no. So what will be the force now? There will be a centripetal force, it will act onto this. So this object it will go in this direction, no. So therefore this force it will always act perpendicular to this displacement, no. So work done by the centripetal force is always 0. So that means if a satellite is revolving around our earth, what is work done by the earth? Gravitational force. So it is 0. An electron is revolving around the nucleus, work done by the nucleus on the electron, right? The force, right? Force of a nucleus on the electron is 0, right? So like that, work done if a force is acting perpendicularly, therefore work is said to be known as 0, right? So these all are the important concepts, no? So like a basic concepts, no? So let us see one simple example. Suppose any one person is there, suppose keeping one luggage, right? So now let us do some simple questions, no? See here, suppose there is a one coolie is there, no? This one coolie, so he kept the luggage on his head, right? So he is standing on the platform, right? He is standing, therefore, so for 1 hour. 1 hour. So if he is keeping your luggage on his head and standing like this, so 1 hour, so therefore there is no displacement, is 0, so therefore work is said to be done is 0. This is one situation. Suppose the same person, what is doing now, therefore he is keeping the luggage on his head, right? He is keeping the luggage on his head, so on his head, and moved some distance here now. Therefore he moved, suppose 10-meter distance. He kept a 10 kg object on his head. So how much amount of work is done now? Here also work done by this person is 0. Surprisingly, here force is there, displacement is also is there, but how the work done is 0? So you see here now, how he is exerting the force? His head is exerting the force on this direction now. This is your head is exerting the force on this direction. In which direction is moving now? In this direction the displacement is there. What is that now? Therefore both are perpendicular, so theta is equals to 90, so work done it will be equal to 0. Clear? So what we will do now, we'll take one object, no? Suppose, so this is one object is there. So this object, what I am doing now, I am lifting this object to this certain height. Who did the positive work and who did the negative work, right? If you know this or no, please comment, right? So let us see here, what we are doing now, we are lifting this object to upward. So who did the positive work? I did the positive work. That means my force is acting in this direction. I am exerting the force in this direction. No, object is also going in the same direction. Therefore, force and displacement both are acting in the same direction. No, therefore we did the positive work onto this. Clear? Who did the negative work now? See here. So if I am moving like this, but gravity is acting downward, mg is acting downward onto this one, no? So weight is acting downward, but object is moving upward. Therefore this is your direction, no? In this direction is moving, but force is acting in this direction. Force is this direction, object is moving in this direction, so both are in opposite direction, no? Work done by the gravity is negative, right? So one more question now, sometimes they will ask, no? Suppose there is a one vehicle is there. This is one vehicle is there. So therefore this vehicle, so now this vehicle is going with because engine is exerting the force, so it is traveled suppose 100-meter distance. So what is the work done by the gravity here now? So very important. So what is the work done by the gravity? So they may ask you, like they will give force is equals to, so suppose 100 newtons, no? Suppose it is like this. Most of the students, what they will think now, force is this one, no? So they will multiply, they will get the answer now, right? But what did I say? What is the work done by the gravity? What is the work done by the gravity? Gravity is in which direction is acting now? This direction, the gravitational force is acting on this one now. So this said it will be mg. In which direction is moving now? In this direction is moving. Therefore 90 degree. So work done by gravity. Work done by gravity is 0. So, but how the force is acting? Engine is exerting the force. Work done by the engine, work done by the engine. So therefore, what you can write it now? So work done by the engine, force into displacement, no? So you can write down 100 into 100. So 10 to the power of 4 joules now. Clear? So there is work done by the engine and work done by the gravity. Like that, compulsory when you are calculating the work, therefore you should mention the force compulsory, right? So with what force you are calculating the work done now, right? So now we'll see. So what are the different type of questions, no, can be expected in right NEET and JEE mains, no? Let us see. First let us go for simple basic questions, no? So one simple basic question we'll see. So ultimately follow the formula, if the work is equals to force into, so displacement into, therefore cos theta. That formula we will always follow, right? So suppose here there is a one object is there, no, therefore here it is about 10 kg it is there, no, 10 kg. Here we are exerting the force of about therefore 400 newtons with an angle of 37 degree, with an angle of 37 degree now, clear? So we are exerting the force at an angle of 37 degree. So we want to calculate, okay, if this is moved some distance, no, some distance, therefore suppose here 10 meters, no, so it is moved 10 meters, how much amount of work done by the force? So here again the same thing, therefore which force is making the object to move, therefore here not 400, no, we'll take it as here 40 newtons, 40 newtons we will take it now, okay. So here what is the work done by the force now, which force is responsible, this force you can component, no, 40 into cos 37, this is the force making the object to move on to this, clear? So therefore here 40 cos 37, cos 37 means what, 37 53, what are these, no, just remember this. So this side it will be like, you know, 3, this is 4, this is 5, so this side it will be 37, this side it is nothing but 53, so this is 90 degree, clear? So from this triangle, no, you can calculate what is the cos 37, cos 37, cos 37 means adjacent side by hypotenuse, 4 by 5, clear? So what you can get it now, you can rewrite it as, so here 40 into cos 37 is nothing but 4 by 5, 5 ones are 5 8s are 8 4s are, therefore 32 newtons, right? So work done, therefore work done is nothing but which force, no, this force you know it, no, that is nothing but 32 into force and displacement, no, so here it is 10, so this force and this displacement both are is 0, therefore angle is 0, cos 0, how much it will be now, 320 joules of work is said to be done, or you can substitute F is equals work done is equals to force into displacement into cos theta, right? So what is work done by the normal, if they are asking, no, therefore what is the normal force, no, this normal force is acting toward this side, so that is nothing but a 40 into sin 37, sin 37 is nothing but a sin 37, so it is nothing but a 3 by 5, therefore it is into 3 by 5, therefore how much it will be, so 8, right, 8 3s are, therefore 24, so therefore here this side 24 newton, this side is 100 newtons, no, therefore this object is not making to move, so work done by the normal, so work done by the normal force, how much now, 24 into some, no displacement is 0, so therefore theta is also 90 degree, therefore work done by the normal is 0, clear? So like this you can expect the questions, no. Now let us see one more question, no, we will include the friction force also, let us see. Here there is a one object is there, again we will take it as 10 kg, so again we will take it as like a force is nothing but a 15 newtons, so making an angle of 37 degree, clear? So one more question we can add it, no, therefore so what will be the work done, right, work done by the force in time t is equals to 5 seconds. So what is the work done by the force in time t is equals to 5 seconds now. So first of all we calculate what is the force here, no. So this force, what we will do now, this force we can have the components, no, this side, so this is 50 into cos 37, just now we written cos 37, 50 into 4 by 5, so 5 tens are, therefore 40 newtons, this side is this much amount of force is acting on this, clear? So this force making the object to move toward this side, right? So initially started from rest. So what is the acceleration here now? Acceleration is nothing but a total force by, therefore net force by total mass. Which force is responsible to make the object to move? This force is responsible to make the object to move. That is nothing but a 40 divided by 10, therefore 4 meter per second square. This is your acceleration. Why we calculate our acceleration? Why? Because we don't know the displacement. we want to calculate the displacement. What is the displacement formula? Here assume that force is constant onto this one. No? So S is equals to ut plus half at square. So this is 0. So therefore here by y is 0 because u is 0. 1 by 2 acceleration is 4 into 5 square. How much it will be now? Therefore 2. So 2 into 5 square is 25. Therefore 50 meters. Clear? 50 meters. So displacement I got it as how much no? How much we got it? That is 50 meters. So what is the work done here now? Work done, it will be equal to force into displacement into cos theta. So force is how much now? 40 Newton. Displacement is 50 into cos 0 because F cos theta is both are acting in the same direction on this. Therefore here how much now? So 2000 joules here. Clear? In this way we can calculate the work done in a given time. Clear? Now we'll do the same type of question. One more type of question, same way. Suppose here same question, same problem. Therefore 10 kg. So we are exerting the force F is equals to 50 Newton. Right? Again, therefore angle is 37 degree. Here we will exert the this is a rough surface. Rough surface is having coefficient of friction is 0.2. So we want to calculate what will be the work done by the applied force and work done by the frictional force and work done by the net force. Right? So what is the work done by this one now? Let us see. Okay. So we'll take directly the displacement here now. This displacement it is given as like a 10 meters. Okay. Again we'll split this force no. Therefore what you will get it now? Force 50 into cos 37. Just now in the previous problem we solved here no. So 50 into 4 by 5. Therefore 40 newtons is the force. Clear? So what is the normal reaction here now? Therefore 50 into sin 37. Sin 37 is nothing but 3 by 5. So therefore it will be 10 newtons. 30 newtons. Right? This is 30 newtons. Therefore upward component. Now downward force is how much now? Downward force is nothing but 100. So what will be the normal reaction now? Why 100? mg, g value is 10. So this should be your normal reaction now. Right? So what will be the normal reaction here now? Therefore total upward forces will be equal to total downward forces. That is nothing but n plus 30. It will be equal to 100. So n should be equal to 70 newtons. Clear? So 70 newtons. What will be the frictional force here now? Frictional force is nothing but a mu times of n. So here mu is nothing but a 0.2 into, so n we already got it now 70. So therefore it will be 14 newtons. So frictional force is maximum static frictional force is only 14 newtons, but this side applied force is how much now? 40 newtons. Definitely this object will move toward this direction now. Clear? Why? This force is more. Now we will calculate what is the work done by the applied force. Work done by the applied force. How much now? What is the applied force now? This side, not this one now. This is making an angle, right? So which is making the object to move toward this side. Therefore here 40. So 40 into displacement is nothing but a 10. So the 400 joules is a work done by the applied force. We are exerted the force now. So due to that force 400 joules of work is done now. And what is the work done by the friction now? Work done by friction. Friction is how much now? Frictional force is, so frictional force into displacement into cos of 180. Why 180? This side frictional force, object is moved this direction now. So frictional force is nothing but a 14 into displacement is how much now? 10 into therefore minus 1. So it will be about minus 140 joules of work is done by the friction. Work done by the friction is how much now? So minus 140 joules. Clear? So sometimes they will ask you what will be the net work done. So therefore work done by the net force. What is the net force here now? Net force. Therefore this side force is 40 Newton, this side force. Therefore here 40 minus 14. This side is net force now. How much displacement now? Therefore it will be the 10 So both are net force is also acting in this direction now, therefore it will be cos 0. Clear? So 14, therefore here how much now? 26 here, right? So therefore it will be 260 joules of positive work done. Therefore if you want to calculate work done by the net force, so just you can add these two, that is 400 minus 140, so you will get it as total net work done. So in this way, if the frictional force is involved, also you need to, you can do the questions like this, no, right? So one more simple, okay, we'll change the friction, no. So therefore here same type but a slight difference here now. Listen. So this is your suppose here 10 kg. Now here we are exerting the force here, no. Force is equals to 50 newtons, also making an angle of 37 degree. Clear? So 37 degree. So now this is a rough surface, no, it is about 0.2. Okay. So therefore now this is more some distance, no, this distance is about 10 meters. Okay. How much amount of work done by the applied force, work done by the frictional force, and what will be the work done by the net force? So here slightly frictional force only, it will be slightly different. This force is there, no, we'll split this one into two components. So what are these two components now here? Therefore this side it will be the component of this one, no? This side it will be the one more component. This force will be splitting. What is, how much now it will be? So 50 into cos 37. So here 50 into sin 37. Clear? So how much, what are the forces here, no? So 50 into sin 37 is nothing but a, so it is 30 Newton. Clear? By why? Because so sin 37 is 3 by 5, therefore 30 Newton. This how much now it will be? 40 Newton. Clear? So just I will rewrite this one, no, diagram here, no. So how the directions are there? So downward direction is there now. Therefore here we can write it as like a, this is your downward direction. Downward direction is how much now? 30 Newton, and this side it is here now 40 Newton. Correct? In which direction is moving now? In this direction now, 10 meters distance. Clear? Okay. So this side one more force is there, that is nothing but a 100 Newton. So because mg, this is your normal reaction. Clear? So what will be the normal reaction here now? Normal reaction. So normal reaction. So this upward total downward forces is nothing but a 100 plus 30, 130 Newtons. Normal reaction. So this side it will be your frictional force, no, that is nothing but a mu into n. So mu is how much now? 0.2 into n is how much now? 130. So 130 means therefore 26 Newtons. So 26 Newtons. Clear? So this side it will be the 26 Newtons. So this side it will be the 40 Newton. In which direction it will move? Definitely this more, which direction of force more is there, no, in that direction only object will move. Therefore so this object it will able to move toward this direction now. So now we will calculate what is the work done by the applied force, no, same thing like so work done by the force, applied force, how much now? Applied force is how much now? This side is 40 Newton, no. So therefore here 40 into distance is 10, therefore cos 0, so therefore 400 joules positive. Clear? So similarly, what is the work done by the friction, no? Work done by the friction, so nothing but a frictional force into displacement into cos 180. Why? So this side it will be the frictional force, the displacement is acting in this direction, so it's 180. What is the frictional force here now? 26 into displacement is 10 into minus 1, therefore minus 260 joules. Clear? So what will be the net work done now? Net work done now, see here. So net work done. Now here net force now we want to calculate. So net force is nothing but a 40 minus 26 into distance is how much now? 10. Net force is acting in this direction now, therefore it will be cos 0. Clear? Cos 0. So therefore here how much now it will be? 40 means is nothing but a 14. So 140 joules positive work is done on this. In this way you need to solve the problems related to this work. Okay. So we'll discuss some more models of this one, no? We'll see. Right? Now we'll go for your work done we know it F dot S. Clear? So work done is F dot S dot product onto this one. No? So we can have force. It's simple basic question. No? This is 2I plus 3J plus 4K. So this is a force which is acting on this one. No? So therefore it is displaces from where to where? No, it is displaces from, so 3 comma 1 comma minus 2 2, therefore 4 comma 1 comma therefore 3, therefore it is displaced from here to here. We want to calculate the work done. How to calculate work done? You have to calculate displacement vector delta r, that is nothing but a final position minus initial position. Now final position is how much now? It is, so 4I plus j plus 3k minus 3I plus j minus 2k. Clear? So here 4I minus 3I, therefore it is I. So j minus j, therefore it is 0, plus 3k minus or minus 2k, therefore 5k. So I plus 5k, this is your position vector onto this. Clear? Now we want to calculate work done now. Work done, how to calculate it now? Dot product. I think you know it, no? So here, what is the force here, no? That is nothing but 2I plus 3j plus 4k dot. So delta r, therefore I plus 5k. I plus 5k here. Clear? So you need to multiply only coefficients now. Therefore I coefficient is how much now? 1. Here I coefficient is how much now? 2. 1 into 2, therefore 2. So j coefficient is not there, therefore it is 0. Therefore like 0 j you can write down 0. Therefore here 4 and 4, these coefficients only you need to multiply. 4 5s are 20. How much now? 22 joules of work is said to be done onto this. Clear? So in this way, like a dot product questions, no, you can solve it. No, sometime they will give this much amount of work is done. What will be the value of in any vectors? No, they will give some unknown values, like that. Also, you can calculate it now, right? So one more method. No, therefore here till now, therefore what we discussed now here we will see, right? Till now, therefore in these situations, no, all the forces are said to be constant here now. We did not see any variable forces now, right? So therefore here we'll see one more variable type of this one. No? Before that we'll see here now work done for variable forces. So here force is not constant, force is changing here now. In that situation now, therefore you can take it as whenever there is a variable is there, you need to do the integration or differentiation now. Integration, so therefore f into, therefore if it is dx is there. If it is variable only along the x-axis means you have to take it as x dx. Suppose if it is a variable in all the directions, no. Therefore, like what you can write it now, this is dot now, right? So variable along all the directions, no. Therefore, f vector dot dr vector. So what is dr vector now? You can write down dr vector is nothing but a, so I into dx plus, dx, anything you can write down, j into dy. Okay, we can write it as, so same thing, therefore dx I cap plus dy j cap plus dz k cap. In this way you can substitute it, no, then you can solve the problems. We'll see one more methods, no. Here integration is there, means immediately you should get it to your mind, that is nothing but a area under fs graph. So area under fs graph, so also will gives us like a work done now. Let us do one simple question here now. See here. Here there is a force is there, no. Here it is a displacement here, no. There is a some graph is given like this. Suppose here, here it is there, no. Therefore, suppose some more extension, no, we'll do it here. Right, here a displacement, no. Right. So here now we can take those values, no. Here suppose it is 10 newtons is there. So therefore here it will be distance is there, no, meters. What you can write it now, here it will be, so therefore 5 meters, no. So here it is about 10 meters, here it is about 12 meters, here it is 14 meters, here it is 16. So therefore this value it will be equal to minus 2 newtons. Okay, right. So here how to do the work done now in this situation, no. So we need to calculate, so work done. So here you have to calculate area under the fs graph. This is f and s graph is there, you have to calculate area. So this area you have to calculate this area. So this area, so what you will get the area now, area is equals to, this is looks like a trapezium, right. So these are the two parallel sides, no, and this is your height. So what is the formula, 1 by 2 a plus b into height. This is your area of the trapezium. Sir, I don't know if area of the trapezium means, just divide this one now, like take it as rectangle and triangle now, so you can calculate it now. Clear? So better we'll use area of this trapezium here now. So here these two are parallel sides. This is one parallel side, this is your perpendicular distance. Sum of the parallel sides, this is one parallel side, this is one more parallel side. Therefore 1 by 2. So parallel side is how much now? This is 10. So one more parallel side is how much now? It is 5. So what is the height here now? This is perpendicular distance. This is nothing but a 10. How much it will be now? This is 5. So 15 into 5. So how much now it will be? Right. So 25, 75 joules is given now, plus. Now here we want to calculate one more area here now. Therefore here, so this area also we need to calculate it now. Therefore, so what is the work done now? That will be nothing but a area. This also looks like a trapezium here, no. So these two are parallel sides. So these are the two parallel sides. This it will be a perpendicular distance. So again the same formula we can use it now. Therefore 1 by 2. Take another color here. So 1 by 2. Therefore a plus b into h. So 1 by 2 a plus b. A plus b is how much now? Right, here this is one parallel side. So how much it will be? 14 minus 12 is nothing but a 2, plus this is a one parallel side. So 16 minus 10, therefore 6, into perpendicular distance is how much now? This perpendicular distance is nothing but a 2. This is here minus 2. So how much it will be? 1. So this is here 8, therefore minus 8 joules. Clear? So what will be the work done here now? So total work done. So work done, therefore positive work is nothing but a 75 minus 8. We get it as like a 67 joules. In this way, if the graphical question is given, no, so that you can able to solve the problems by finding the area. And also if it is like a force is given as a function of distance here, no. So if it is for variable forces, no. Therefore here, so this is your variable forces. Variable force. So for force is a function of distance means like this, no. Is a force is a function of your displacement like this. You can calculate it now. Clear? So we'll do 1 or 2 questions now. So based on this concept, we'll do it now. See here. Now let us do so one question now. Therefore suppose here force is given as a function of, so like ax plus bx square is given, no. So like this. So is a function of x and x, therefore it is a force is a function of x. Only one dimension it will be there. So what will be the work done? Work done in stretching from 0 to L. So we want to calculate work done from stretching from 0 to L. So here force is a function of distance only, therefore you can rewrite it as, so work done it will be equal to F into dx. Clear? So from where to where now? So force is equals to, therefore ax plus bx square into, therefore dx. So this x values varies from 0 to L, and a and b are constants is given, no. Therefore now you can rewrite it as, therefore here a into integral x now, therefore x square by 2. So plus integral of x square, so it's nothing but a b x cube by 3. So we can apply the limits here, no, 0 to L. So upper limit, no, therefore A L square by 2 plus B L cube by 3. So minus, therefore x value is also 0, this x value is 0. So therefore remaining thing will be the 0. So this it will be your work done in this situation. Clear? Now, so we'll do one more question here, no. Suppose one more formula is given, no. Therefore force is equals to, it is given as, therefore here, now 2x, therefore I cap plus 3y square, therefore j cap. So this is here one function is given, therefore this force is different along x axis and y axis onto this one. So in that situation, no, okay, even if it is z axis also you can take it now. Therefore here therefore here you can rewrite it as minus 3z square, therefore k cap it is, right? So this is one function is given, no, force function, no. So now we need to calculate work done in moving from, therefore 1 comma 2 comma 3 to, therefore minus 3 comma 4 comma, so therefore minus 5, something it is given like this, okay, some values. Now we have to calculate work done in this situation, no. See here, therefore this is your x1 comma y1 and z1, this is x2 y2 and z2. Clear? So here we want to find the work done, no. Here how to calculate now work done, it will be equal to f dot dr. So here you can rewrite it as f dot dr. F is nothing but a 2x I cap plus 3y square j cap minus 3z square k cap. So in dot, therefore dx I cap plus dy j cap plus dz k cap. Clear? So do the dot product here, no. What you will get it now? This integral 2x, that means work done separately along the x axis, no, that is nothing but a dx. So x values, what is the parameters are changing now? Therefore, so 1 to, therefore minus 3 plus. So here you can write down integral 3y square into dy. So from where to where? 2 to 4. 2 to 4. Here 2 to 4. Clear? Similarly, so this is minus, therefore you can take it as minus 3z square into dz. So from where to where now? 3 to minus 5. 3 to minus 5. Here, therefore we can just simplify this one, no. So just mathematics here, no. So here 2, therefore 2x square by 2 integration, no, therefore 1 comma minus 3 plus 3y cube by 3. So 2 comma 4, 2 to 4 minus 3z cube by 3, 3 comma minus 5. Clear? So just therefore you can calculate, cancel it, no. So this cancel. So this is how much now? Minus 3 whole square means nothing but it is 9. So minus 1. So plus. So therefore here 4 to the power of 3 minus 2 to the power of 3. So minus here. So minus 5 to the power of 3 minus 3 to the power of 3. Clear? So this is 8 plus 4 4s are 16, 16 4s are 64. So this 64 minus, therefore it is 2 cube is nothing but 8 minus, so minus 5 cube means 25 5s are 125 minus 125. So minus 9 3s are 27. So 27. Clear? So just mathematics onto this one, no. Therefore, right here 64 minus 8, therefore here 4 gone, 60 minus 4, that is nothing but 56 minus minus 27 here, no. 3 12 1, therefore 5 1. So therefore 152. So 152 160. So here 160 you can add it, no. Therefore 6. So that 11 216 joules of work is said to be done in this one. Clear? So just is a mathematics onto this, therefore you can calculate. So like this, if it is a different functions is given, no, you can able to calculate it. Clear? Now we'll see one more different questions here, no, different concepts, no. See here, suppose here there is a one inclined plane is there, this one inclined plane. So I'll take it as like a smooth inclined plane now, therefore theta. Okay, so this is a question here. Right, so we'll see here, no, therefore here there is an inclined plane, this is theta, therefore this is assume that this is a smooth inclined plane. Okay, so this is a question, no. So here what will happen, no, this is your h is a height. Okay, then you can understand here, no. So yeah, so what is the work done by the gravity now, right? So what is the work done by the gravity now? Most of the students know. So gravitational force in which direction is acting now? Therefore gravitational force is acting in this direction. So work done by gravity, work done by gravity, so you can rewrite it as this side it will be the mg. Okay, this is moving but the downward force it is there, no, and it is came from here to here, this downward, no, therefore it will be mgh. If you know this is a height, or this one it will go this direction, no, therefore here mg, so weight component it will be there, therefore it will be mg sin theta. So it will move in this direction, no, therefore it will be, suppose m length is l, so work done by the gravity also we can rewrite it as, so work done by gravity, so it will be equal to mg sin theta into L. Clear? So this it will be the work done by the gravity, either this formula, both are same only. How it will be the same? You can rewrite it as sin theta is equals to h by opposite side by hypotenuse now. Therefore h is equals to L sin theta, just you can substitute here, no, h value mg into L, so sin theta, so both are same only here, right? So work done by the gravity, so you need to take it along this one now, or if you know this height, no, this also it will be the fine one. Clear? So we'll do one question here, no, related to this. Now let us do one here. So this is theta is equals to 37 degree, so we'll take it as a rough, right? We'll take it as rough here, no? So this total length it will be equal to, therefore it is 5 meters, suppose length is equals to rough surface here now. Therefore here the mass is there, so mass of about 10 kg is kept here now. Therefore so rough surface means mu value is equals to 0.2. Now we want to calculate work done by the gravity and work done by the friction and net work done, no, we want to calculate it now. Clear? So work done by the gravity, what is the formula, you know? Work done by gravity force, it will be equal to, therefore mg sin theta into L. Therefore m is how much now? 10 into g value is 10. So sin 37 is nothing but 3 by, so 3 by 5. Clear? 3 by 5 into length is equals to 5 meters. Therefore 5 cancel now. So this is 300 joules. Therefore this it will be your work done by the gravity. So work done by the friction, what is the frictional force here now? So this side is moving, so this side it will be your frictional force, no, frictional force is nothing but a mu mg cos theta. Clear? So why? Normal reaction is upward direction now. So work done by, therefore frictional force, no, therefore you can write it as like a mu mg cos theta, this is a frictional force, into distance into cos 180. Clear? Why 180? Because so frictional force is acting toward this side, but object is moving in this direction. Clear? So first of all you need to check it now whether it will move down or not. No, definitely it will move down, you just check it now, downward force, right? Mu is how much now? 0.2. M is how much now? 10. So g value is 10. Cos 37 is nothing but a 4 by 5. So into length is equals to 5 into, therefore minus 1. This will get cancelled out. So this it will be the 2. 20, therefore it will be the 80 minus 80 joules. This is your work done by the frictional force. So what will be the net work done now? Net force, net work done. Net force is how much now? So net force is nothing but a mg sin theta minus mu mg cos theta into L. So or instead of that one, no, you can subtract this, you can get it your answer. 300 minus 80. So therefore you can write down, therefore 220 joules, right? So this is your net work done onto this. Clear? In this way you have to calculate. So work done by the inclined plane onto this. Clear? You understood, no? So here one more important concept, no? Let us see. Suppose there is a one more concept, no? Suppose here, suppose there is a one block is there now. This is one block. Okay. So this one rope is there. So rope is negligible, no? Therefore negligible mass, it is connected with the mass is m. So therefore this is pulled by the one person now here onto this. So he is pulling this one now, therefore upward. So he is pulling upward with an acceleration of therefore g by 2. Clear? So it is pulling upward with a acceleration of g by 2. Therefore now we need to calculate what will be the work done by the tension, or work done by this person, or work done by the gravity. So first let us calculate what is the, okay, after it is pulled to certain height now, therefore this is height is h. It is pulled to this height now. Clear? So we want to calculate what is the work done by the tension and work done by the gravity. So what is the work done by the gravity now? So work done by gravity. What is the work done by the gravity here now? So gravity is acting which direction now? Downward, therefore mg. So but downward force is acting now, but in which direction is moving now? It is moving in this direction. So therefore gravity is acting downward, but it is moved opposite now, therefore cos of 180. How much it will be now? Minus mgh. This it will be the work done by the gravity onto this. Now, so work done by that person or work done by the tension, no? So we can calculate it, no? So work done by the tension. So this tension is nothing. What is the tension now? It is going upward. We studied. So one already lift problems. No, I already kept one trick onto this. In already one video is uploaded based on the trick related to that lift problems onto this one. No, please, I'll keep that video. So on the iCard, no, please go through it. So here one simple thing you can remember that if it is going upward with an acceleration, you have to add the weights. That means weight will increase. So if it is going downward with an acceleration, weight will decrease. That's all. So remember that it is going with an acceleration now. Tension you can rewrite it as how much now? M into g of A. That is nothing but g by 2. How much it will be now? Therefore 3 mg by 2. This is your tension on this one. Tension is how much now? 3 mg by 2 into, therefore what will be the distance here now? Therefore distance is h. So tension is acting this direction is only moving, therefore cos 0. Therefore how much now? 3 by 2 mgh. This is your work done by the tension or work done by that person now to this. Clear? Therefore what will be the net work done now? Net work done, therefore, so net work done. So what will be the net work done now? Therefore 3 by 2 mgh no, minus mgh. So 3 by 2 mgh minus mgh. So what you can write it now? Therefore mgh by 2. So with this it will be the net work done onto this. Clear? In this way you can calculate. So work done in different scenarios onto this one. No? Let us see. Clear? So one more important one more concept. No? Suppose there is a one lift, one pulley is there, no? This is one pulley, clear? This is one pulley. So here there is a masses are kept here, no, like this, okay? So this is about 2 kg, this about suppose it will be 7 kg, 7, okay. So this is about 8 kg, 8 kg. Initially, therefore, initially it was released from rest, no, from rest. So we want to calculate what will be the work done. So work done by the tension in time t is equals to 2 seconds. After time t is equals to 2 seconds, right? So therefore, first of all, you need to calculate work done by the tension means what you have to write, work done by the tension on this one, this tension now, right? So work done by the tension here, tension here, tension into displacement here, right? So tension you have to calculate work done by the tension, so tension into the displacement. First let us calculate the tension here, so already I uploaded one video, so to calculate the tension very easily. So tension, what is the formula? 2m1 m2. So what is the formula? 2 into m1 m2. Therefore multiply these two, 2 into 8 by m1 plus m2 is nothing but 10 into, therefore g value is also 10, no, therefore you can get cancelled. So 16, 16, 32, therefore 32 newtons will be the tension here, right? So what is an acceleration? This also I already taught in our video, tricks video. So I'll keep that video here in I button. Please go through it now. So therefore here subtract these two masses, no, therefore 6, add these two masses, therefore into g, so g value is also 10, no, therefore 6 meter per second square. So this is an acceleration now. So now we want to calculate intention to, work done in 2 seconds. In 2 seconds, how much distance it will travel? Let us see. It will travel some distance here, no? Suppose here, suppose some distance now. And this also it will travel same amount of distance upward after this. Clear? So same amount of distance. So how much distance it will travel? S is equals to ut plus half at square. This is 0 because initially started from rest, no? A is equals to 6 into 2 square. So how much now? Therefore it is 12 meters. So it will travel 12 meters downward. This also it will move 12 meters upward. So now we want to calculate what is the work done now. Work done by the tension, no? See what is the total work done by the tension. Very interesting result here, no? So work done by the tension. So work done by the tension, no? So this tension, what is happening now? This side it is moving, tension T. Okay. So 32 newtons into, so this tension is toward this side and the distance is toward this side, that is distance is 12 into, therefore it is minus 1. Why? Because tension is toward this side, distance is moving. Work done by this one is negative. Next one is plus. So this one is tension is toward this side, tension is 32 and distance is also 12 meters. So it is into 12. So but tension and distance both are same direction, it is plus 1 now. Clear? So here 32 into 12 minus plus into 32, therefore work done by the total tensions, so it will be equal to 0. Very interesting result, no? So based on this concept only, work done by the tension in a constrained motion is always 0. So you can use this condition, no? So you can solve lot of problems in the constrained motions, no? So that proof is given from this problem now. Clear? In this way we can calculate, so what are the problems which are asked in the work done, so you can calculate all these possible ways now. In the next topic, no, we'll study about energy, right, and how to calculate the energy and work energy theorem, therefore applications of this, no, and law of conservation of energy also we'll discuss in the next part of this video now. Please, thank you, please subscribe to my channel now.